All right, so now we're on the last video of section 7.5. And remember, in this section, we were going to use the side splitter theorem and the triangle angle bisector theorem. We've already done the side splitter theorem and the corollary. Now we're going to strictly focus on the triangle angle bisector theorem. So that's our essential understanding today. It's going to be using the bisector of an angle. All right, and what this triangle angle bisector theorem states is if a ray bisects an angle, so if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. So what that means is that this segment CD over DB, because this is the sides that's created when it divides the opposite side of a triangle into two segments, that those two sides will be proportional to these two sides here. So we can create a ratio that CD over DB is equal to AC over AB. All right? And remember, when you're doing these proportions, just like I said in the other video, it does not have to be just this way here. There's other proportions that can be created that will also be equal. You could do CD over AC is equal to DB over AB, right? That would also create congruent or proportions, two ratios that are equal to each other. And if you notice, when you go to cross multiply, you would cross multiply CA and DB here. Well, CA and DB are still being cross multiplied here. So as long as you're staying consistent, it doesn't really matter exactly how you set it up. So let's go ahead and use the triangle angle bisector theorem. So since we know that it is bisecting our angles with these arc marks, I know that I can create ratios that are equal to each other, or I can create a proportion. So that means 9.6 over top of 16, because this is the segments created from the opposite side when it's intersecting, is equal to y over 24. Now, when I say about being consistent, 9.6 is part of this left triangle. So when we created this first ratio, we did left triangle over top of right triangle. So when we created the second ratio, we had to stay consistent. We had to stay left triangle over right triangle. We couldn't all of a sudden say 24 over y, because then we weren't being consistent in the way that we were comparing them from this triangle to the right one. All right, then from here we would cross multiply. So we'd get 9.6 times 24 is equal to 16 times y. And 9.6 times 24 is 230.4, which is then equal to 16y. And then we will divide each side by 16. So divide each side by 16. And y is then equal to 14.4. All right, so that is the value of y. That is what this side length would be. Since there's no units, you don't have to say 14.4 yards or anything like that. That's your final answer. All right, now that's it for this video, and that's it for chapter 7. This is the last section of that chapter.